Our Newton spring scales actually have two values on them. However, only one value will always be right. The side that will always be right is the Newton side, which is the side that we're going to use today. As long as you are, in fact, no matter where you take this spring scale, to any planet, to the moon, whatever, it will always measure the correct number of newtons. However, if you use the other side, which is the gram side, it will only be correct here on Earth. Because when we take it to another planet, it will actually show that the thing will have fewer grams, but indeed the grams do not change. So something that was 120 grams here on Earth would still be 120 grams on the moon, but on this scale it would actually only measure 20 grams. So the scale is not right when you leave Earth. Okay, but we're going to use the Newton side. The Newton side will always be right because on Earth, 1.6 newtons, okay, would be the weight of an object. You took that same object to the moon, it would weigh 1/6 the amount, and so it would actually show 0.2 newtons on the moon, which is correct. Okay, so that's just a little extra information. What you need to worry about for today. First thing you need to worry about is you need to make sure you understand what the values represent here on our spring scale. You'll notice that we have numbers of 0, 0.5, 1.0, 1.5, 2.0, and 2.5. The problem is, or the issue is that there are 10 values here between 0 and 0.5, so each value is going to be 0.05. Okay, so it's going to count 0.05, 0.1, 0.15, 0.2, and then 0.25 in the middle, which actually you should realize that because half of 0.5 is 0.25. All right, and so just make sure you realize and understand what each of the values mean so that when you're reading this, you get the right values and you record the right values. All right, any questions? Go ahead and ask your teacher what questions you have about how to read these particular spring scales because they are a little bit different than probably most things that you see. All right, so today's lab, what we're going to be doing is we're going to be experimenting with different surfaces and the friction value of each of these different surfaces. The way we're going to do this is we're going to use a block of wood. We're going to use a 200 gram mass. We're going to use a 100 gram mass, our 4-surface card, and of course our Newton spring scale. We're going to start with the smoothest surface here on the end first. So we're going to start with the block of wood. We will start with 100 grams. You will place the 100 grams on top of the block of wood. You will hook your Newton spring scale into this little hook, and then you will pull the weight or the wood block nice and steady. You will notice that the value is right here where it looks like we're at about halfway, so that would be 0.25 newtons. Okay. Once you get it across, let's go ahead and let's pull it back. Let's just do it one more time just to make sure that that's exactly what we have. And you notice that we did end up stopping at the same spot. Now, when you first pull it, or if you pull it really hard or really fast, you're going to get a higher value. So you want to make sure that you don't record the initial value, but you record a nice steady pull, the value and the amount of force that it takes to move the 100 gram. Once you've done the 100 gram a couple of times, we'll take that off, put the block back. We'll now do 200 grams, same motion, same action. Okay, and now pull that, see what the value is, pull nice and steady. Once you finish the 200 a couple of times, you will then go back and now we'll do 300, and we'll get 300 by doing the 200 and the 100 together will give us 300. So you should have recordings of values of 100 grams, values of 200 grams, and then values of 300 grams. At this point in time, what you will do is you'll go ahead and graph those three values on our graphs using the color that we've selected for that particular surface. Remember, we're going to graph by the surface. We're going to graph by the mass, which is these values, okay? And then we're going to graph by the Newton value, how much strength or how much pull it took for us to move this object. Once you have this surface graphed, you record all the values and graph this surface, you will then do exactly the same thing on each of the other surfaces. So just like we did before, we will start with the 100, okay? We'll pull nice and steady, then we'll go to the 200, okay? Then we'll go to the 300, then you will graph this surface. Once you finish graphing this surface, then you'll go to the rubber surface. You will then do the same exact process, do the 100, 200, 300, graphing the rubber, and then finally do it to the cork. Okay? Any questions? Go ahead and get started. You will get started with the smoothest surface, the cardboard surface. You will then do all three there, and then you will graph it before you move to the next surface.